Hello guys and welcome to Coding Minutes. Today we'll speak about HTTP. Open any website and hit refresh. It feels instant. But under the hood, refresh triggers a pipeline, a chain of steps, and debugging becomes easy only when you know which steps failed. Here is the mental model for this video. A request is not just a get, it's a journey. And every common problem you have seen, timeouts, 404s, CORS errors, TLS failures, happen at a specific stage of the journey. So let's do a quick question. When you press enter, do you immediately send HTTP? No. First your computer must resolve the host, open a connection, secure it, and only then send HTTP. In this video we will go step by step, and for each step I will show you what breaks and how it looks when it breaks. By the end you will be able to say this failed at DNS or this reached to server but routing return 404. Let's start with a simple definition of HTTP. HTTP is a protocol for exchanging messages between a client and a server. A client sends a request, the server returns a response. That's the core. Now, the most important property, HTTP is stateless by default. Stateless means each request is independent. The server does not remember previous requests automatically. So, when someone asks, how does the server know it's me? The answer is, it doesn't, not because of HTTP. The server only knows because we add state on top. Cookies, sessions, JWT tokens, API keys. Usually 2 headers. Practical takeaway. When login behaves weird, it's usually not HTTP is broken. It's the state layer. Expired token, missing cookie, invalid session. Keep this sentence in mind. HTTP is simple. State is something we build on top. Before HTTP even begins, the browser needs an address. That address is the URL. Let's break down. The scheme is HTTPS. This tells the browser to use HTTP secure with TLC. The host is api.example.com. This is the most important part early, because it must become an IP address to DNS. The path is users. That's the resource the server will route to. And the query is page equal 1. That's filtering, pagination, sorting. Parameters for endpoint. DNS translates a domain name into an IP address. Humans use names. Computers use IPs. You ask, who is api.example.com? And DNS replies, here is the IP address. And here is an important detail. DNS is often cached by your OS, browser, router. The biggest point, if DNS fails, HTTP never starts. You don't get a 404, you get timeouts or could not resolve host. So, if someone says API is down, first question, can you resolve the host? After DNS, you still don't send HTTP yet. First, you open a connection, usually TCP. TCP starts with a 3-way handshake. Syn, ACK. Only after ACK is complete can HTTP flow. Port method. HTTP is typical 80. HTTPS typically 443. If the connection can be established, you will see timeouts, again before HTTP. If the URL is HTTPS, there is an extra handshake, TLS. TLS verifies certificates, negotiates keys, and encrypts traffic. After TLS is established, HTTP travels inside the encrypted tunnel. Important notice. HTTPS secure transport, not your business logic. An HTTP request has 3 parts: start line, headers, and optionally a body. The start line includes method, path, and version. Headers are metadata, and this is where real bugs hide. Example authorization, content type, accepts. The body is the payload, usually JSON. Common is put, post, and patch. Practical rule. If something fails, check methods, headers, and body, not just the URL. Methods are contract. Get for reads, post for creates, put for replace, delete for removes, and patch for updates. Now the deeper concept, idempotency. It means repeating the same request produce the same result. Why it matters? Retries happen. Mobile networks retry. Load balancers retry. If you don't design for it, you can create duplicates, double orders, double payments. A response also has structure, status line, headers, and body. Status code are the language between client and server. 200 OK, request succeeded. 201 created, resource created. 204 no content. 200 bad request. 201 unauthorized. 203 forbidden. 404 not found. And 500 server error, internal server error. Cache is an HTTP superpower. First request, server returns 200 plus an ETag, like a fingerprint. Second request, client sends if none match with that ETag. If unchanged, server replies 204, not modified, nobody. HTTP is stateless, but apps need identity, so we attach identity to headers, cookies, or bear tokens. This is a little comparison between these two. I encourage you to press pause and read it. Now CORS. It's a browser rule, not the server refusing you. The browser may send an option, pre-flight, request first. This is the real HTTP lifecycle in one screen, the network timing waterfall. Every request has phases, and you can literally see where time is spent. First, you may see queuing and stalled. That's the browser waiting to schedule the request. Then DNS lookup, converting the domain name into an IP address. If DNS is cached, this can be almost zero. Next is initial connection. This is basically the TCP connection setup. After that, CCL. That's the TLS handshake, the HTTP security part. Then we have the actual request response. Request set when waiting for server response. This is often called TTFB, time to first byte. This is usually the most important one for backend developer because it includes server processing time. And finally, content download. Downloading the response body. After you see the timing, the next step is what exactly was sent. That's the headers tab. In the general section, you can quickly confirm the request URL, the request method, and the status code. This alone helps you debug most issues. Wrong URL, wrong method, wrong status. Then you have request headers. This is what the client sent. And response headers. This is what the server replied with. For example, this is where you'll see things like content type, cache control, and sometimes CORS headers. So, timing tells you where time is spent, and headers tells you what was actually exchanged. Finally, debugging. Open DevTools network tab and check in order. URL, method, status, header, timing waterfall. That's the full lifecycle. Thank you for listening to Code in Minutes. See you in the next one, guys. Bye bye.